Hey everyone, let's jump right into today's explainer. We're unpacking an incredibly clear, really powerful lesson straight from the Sense of Study platform, all about independent events. Probability can sometimes feel like a total maze, right? But Sense of Study has this brilliant way of just cutting through the noise, and we're going to look at exactly how they do it. So get ready, because we are going to completely transform how you look at chance and probability.
I really want to anchor our entire explainer today on this one brilliantly intuited mantra from the lesson. The coin can't see the die. Just picture it for a second. You've got a coin in your right hand, a six-sided die in your left. If you flip that coin, does it have eyes? Can it literally peek over at the die and say, oh, hey, you're going to roll a 4? Well, I better land on tails. No way, right? Of course not. If two random processes physically cannot influence each other, they simply do not update each other's probabilities. It's such a simple idea, but it's the absolute bedrock of everything we're about to cover. But just to get our gears turning before we dive into the heavy lifting, consider this classic probability mystery. Imagine you draw a heart from a standard shuffled deck of cards. Does that single action change your chances of drawing a second heart right after? Just hold on to your answer for a minute, because understanding exactly why this happens is your real key to mastering this stuff.
So here's our roadmap for this Sense of Study explainer. We're going to start with the core definition, look at why it actually matters, figure out how to spot it in the wild, dodge the infamous mutually exclusive trap, put the math into action, and wrap up by avoiding those pesky test day mistakes.
All right, part 1, the core definition. What exactly is independence?
The absolute crucial point here is this. Independent events are two events where learning the outcome of the first has strictly zero effect on the probability of the second happening. Now, notice I didn't just say they're separate topics. That is a massive trap. Independence isn't about, whether one event is about the weather and the other is about playing poker. It's a very strict mathematical test. After you learn event A happened, does your estimate of event B's probability change? If the answer is no, boom, you have independence.
Moving on to part 2, why this matters. And spoiler alert, it's the ultimate shortcut. You might be wondering, why make such a huge deal out of this definition? Well, because getting this right is your magic key. If events are independent, you get to use the easy math. You literally just multiply the probabilities together and you're done. But if they're dependent, you're forced to use conditional probability, which is frankly significantly harder. Misdiagnosing independence is the single most common source of error you're going to see on probability tests. Nailing it is your free pass to simple multiplication. So, part 3, how to spot it. Let's look at the diagnostic checklist. Here is a 4-question checklist you should run through before you ever write down a formula. Number 1, did the sample space change? Number 2, is there replacement? Number 3, are these separate random processes? And 4, did the probability change? I really want you to pay special attention to number 2 here. The phrase with replacement is a massive flashing green light for independence. It essentially means you hit reset on the universe, bringing it back to its exact starting state before that second event even happens. Let's put that checklist to the test with a quick check. You draw a card, you do not replace it, and then you draw a second card. Are those two draws independent? Think about it for a second. Actually, the answer is a resounding no. By holding on to that first card, you just shrunk the entire deck. The sample space is different, the starting state is completely different, and that phrase, without replacement, is your massive red flag that your events are now dependent. Which brings us to part 4, the mutually exclusive trap, or the lookalikes.
We really have to talk about the arch nemesis of probability exams. A lot of people confuse independent events with mutually exclusive events. I get it, they sound like they should mean kind of the same thing, but they absolutely do not. When we break them down side by side, independent means one has zero effect on the other, just like the coin and the die. They can easily happen at the exact same time. Dependent means one changes the other, like our shrinking deck of cards. But mutually exclusive, that means the two events cannot possibly happen at the same time, period. If you roll one single die, you can't get both a 2 and a 5 on that one roll. If one happens, the other has a 0% chance of happening. So yeah, definitely not synonyms. All right, part 5, solving probability. Let's see this math in action. Here is the golden formula for independent events. The probability of A and B happening together is simply the probability of A multiplied by the probability of B. P of A times P of B. That's literally it. No complex conditional adjustments, just simple multiplication. Let's walk through this sequentially using our classic coin and die problem. Step 1. Identify the events.
Say we want a heads and a roll of 4. Step 2. Decide independence. Well, we know the coin can't see the die, so yes, absolutely independent. Step 3. Find the individual odds. A fair coin is 1 out of 2. A fair die is 1 out of 6. And step 4, just multiply them together. 1/2 times 1/6 equals 1/12. Look at how beautifully easy that math is when you've correctly identified independence.
Now let's contrast that with our dependent card problem without replacement, where we want to draw 2 hearts. Step 1, your first probability is 13 hearts out of 52 cards. But for step 2, because you kept that first heart, your deck is changed. There are only 12 hearts left and only 51 cards total. So your conditional probability is 12 out of 51. Step 3, notice how those odds changed from the first draw to the second. Step 4, you have to multiply conditionally, which gives you 1/17. See? That shrinking deck forced us into the harder math.
Let's challenge you with one more quick check straight from Sense of Study. If the probability of event A is 0.4 and event B is 0.5, and you are explicitly told they're independent, what's the probability of them both happening? I bet you've got this instantly. You just multiply 0.4 and 0.5, giving you a smooth, clean 0.2. You didn't even need to know what the actual events were, just that they were independent. And finally, part 6, avoiding mistakes and test day traps. Now that you have the tools, we need to make sure you're fully armored against the trick questions test writers love to throw your way. Let's do a rapid-fire summary of the main traps. First, assuming things are independent just because they sound unrelated in a word problem without actually checking the math. Always verify. Second, falling into the trap of multiplying directly when the events are actually dependent. Always remember that shrinking deck of cards. And third, confusing mutually exclusive with independent. Remember, independent means they don't affect each other at all. Mutually exclusive means they outright block each other. And I want to leave you with this incredibly provocative thought pulled right from the Sense of Study FAQ section. It is a genuine aha moment. Think about it. If mutually exclusive events cannot possibly happen at the same time, doesn't that logically make them the most heavily dependent events of all? Because if you learn that event A happened, the probability of event B doesn't just change, it violently slams down to 0. They are the ultimate dependent events. I really hope this explainer has shifted how you see probability. Keep looking for those connections. Always ask if the universe reset itself, and I highly encourage you to keep diving into this fascinating topic.